Okay. So today we're going to start off just talk about what chemistry is, okay? Because if we're going to study it, we need to know what we're talking about. So I do want you guys to copy down this first definition right here. I'll highlight it. But chemistry is the study of matter and its interactions, okay? Chemistry is the study of matter and its interactions. Take a second to copy that down, just so we have a working definition. But chemistry is the study of matter and its interactions. So chemistry is the study of matter and its interactions. Okay, so if we're going to talk about chemistry, we got to talk about matter. And just so we have a definition of matter, you guys don't need to copy all this down. I'll tell you guys the important parts, but I do want you to write down the term matter. So matter is basically anything that has mass and takes up space. The definition I do want you to write down, so write the parts I underlined, but matter is anything that's physical. Okay, so it's an easy way to think about it. Matter is anything that is physical. Okay, so for this class, easy way to think about it is solids, liquids, and gases. Yeah, I know there's other types of matter you might have learned about, like plasma and things like that. But for this class, we're just going to talk about the three basic ones. So matter is anything that is physical. Okay. So things that are not physical are things like, abstract concepts, time, your emotions. So that's my way of saying your emotions don't matter in this class. I'm just kidding. I care very deeply about all of you. Just the part where it says matter, anything physical. All right, so today we're going to talk about what matter is made out of. And all matter in the universe is made out of these tiny particles called atoms. You guys don't need to write the full definition. Just write down that word atom somewhere on your paper, because we're going to talk about them in a second. Okay, but atoms are pretty much like the Lego blocks that make up everything in the universe. Okay, so the air around us is made out of matter. Atoms. Your bodies are made out of atoms. The desks you're on, made out of atoms. The sun is made out of atoms. Everything is made out of atoms. Okay. Again, you don't need to copy all this down, just the part I highlighted. Just write down the term atoms. Okay. Now, atoms are super duper small. Okay, they're so small that one drop of water, it contains 1 billion trillion of them. Okay, and just for reference, that's how big that number is. So they're really, really small. Okay, but they're there, and when they come together, they make pretty much all the things that we interact with in the universe. Okay. All right, now I want you guys to look at the periodic table that you guys picked up on your way in. You guys have probably seen this before, right? It's the periodic table of elements. Okay, yes.
You have to remember all of this?
Yes, no, I'm just kidding. No, you will never have to memorize the periodic table. I don't even have it memorized, just to be honest. Okay, but you just need to know how to use that table for the exam, things like that. Okay. So I do want you guys to write this definition down. So the periodic table of elements talks about elements, right? And elements are all different types. Yeah, you can take this one. Okay. Elements are basically the different types of atoms that exist. So we know about 118 of them, and these are the types of atoms that make up everything in the universe. Okay, so you can think of them as like different versions of the same thing. They're all atoms, but these are all different types of atoms. Okay, and we call those things elements. Yeah, just write the term atom somewhere, but you do want to write this definition right here about elements. Okay, so today I'm going to teach you guys how to read two of the things on the periodic table. So I have a little sample right here, but this is all on the top left of your periodic table. So I want you guys to look at the top left of your periodic table. Okay, those are for you guys to keep. You're going to want to hold on to them throughout the year. We're going to write on the periodic table. That way it has some of the notes, and when you look at it for your homework and things or your assignments, it's an easy reference for you guys to find things. But today we're going to be talking about two of the things. So let's take a look at hydrogen. And on your periodic table, I want you guys to draw a quick arrow to that big letter in the middle. Okay, that right there is called the element's symbol. Okay. So every element has its own box on the periodic table, and that big letter or maybe two letters, that's called the symbol. And this is how chemists communicate or talk about different elements on the table. So this thing in the middle is the symbol. Okay, and obviously the word on the bottom, you guys can probably guess, is this is going to be the element's name. Okay, so you guys can write that down. So we got the symbol and the name. You can use either one. Whenever you're talking about an element, you can write the full name if you want, or if you want to be quick and efficient, you can just write the symbol. Okay? And that'll make perfect sense. Okay, so on your notes, let's do our first example problem of the year. We're going to write number 1. Okay, what is the symbol for hydrogen? Well, if we take a look right here, hydrogen is the first box on the periodic table, and the symbol is going to be capital H. So we're just going to write capital H. Okay, and there you go. That's how easy it is to figure out what the symbol of an element is. Yes?
You have to write down
No, please don't. Yeah.
the
Yeah, you can just write number 1. Again, these questions are all posted on Canvas. So if you ever look at your notes and you don't know what the answer is for, you can go back. But for this class, you don't need to copy down the question. Unless I get like really mad at you guys and just make you write. Number 1 is H. Symbol for hydrogen is H. Okay, so I'm going to give you guys about 2 minutes now. I want you guys to try number 2 and number 3 on your own. Again, you don't need to copy down the question. Just on your notes, you can just write number 2 and then the answer. I want you guys to find the symbol for helium. So you're going to have to look around on the periodic table. And then after that, I want you guys to do number 3, the name of the element Hg. Okay, so I'll give you guys about 2 minutes. You can work with the person next to you. You can check your answers with them when you're done. But I'll give you guys 2 minutes to try out those, and then we'll go over them, and then we'll move on to the next topic. Okay, so let's take a look at number 2, a symbol for helium. So for this one, we'll go to the periodic table. And then if we look for helium, it's on the top right. You'll see that helium symbol is He. So that just make sure that for number 2, you have He. Okay. All right, so one thing I do want to mention about writing the symbols is make sure that you guys copy it down exactly as it is. So if it's capital H, write capital H. And if it's lowercase e, make sure you write lowercase e. I know some people write like all caps or all lowercase, but when it comes to element symbols, you have to write it. The capitals and the lowercase matter. So I know that some people write a certain way, but please just make sure that for clarity of communication that you guys copy it down exactly the way it is on the periodic table. Okay. All right, let's go to number 3 now. Number 3, we were looking for Hg. So Hg, we have to go down a little bit on the periodic table. And so if you take a look here, we have Hg, and the name for Hg is mercury. Okay, so just make sure for number 3 that you write mercury. Okay. And I wanted to talk about that one because a lot of times for the elements, it's not going to be based on the letter that's in front of the names. The name can be a little bit different than the symbol. Okay, so just keep that in mind. Another example is like gold. It starts with G, but it's AU. Silver is AG. So just keep that in mind. Sometimes the name and the symbol might not really connect for us in English, but just keep that in mind. Okay, the symbol can be different from the name. All right, but any questions about numbers 1, 2, and 3? Yes.
numbers like or just any of them, it's like 190.23.
Yeah, we're gonna get to that later. Yeah, that's gonna be in unit 2. So we'll talk about that in like October. Yeah, good question though. Any other questions? Okay, so let's move on to the last topic of the day. So we have elements which are just atoms, right? We said they're like the Lego blocks that make up everything. But these are usually not that fun to talk about. The ones that are really fun and the ones that we'll be doing in our labs are things called molecules. So I want you to write this down, the sentence that I highlighted. Okay, you guys have probably heard atoms, molecules, and you might think they're the same. And usually in regular life, we kind of use them interchangeably. But atoms are like the Lego blocks that make molecules. Okay, they combine, they fuse to form molecules. So molecules are like the big structures And then atoms are the little things that combine to make these molecules, okay? Just make sure you copy that sentence down. That way you can differentiate between the two. Okay? Atoms, they combine to form molecules. Molecules are like the big structures. All right, so let's talk about how we communicate molecules, okay? So we talked about elements, how we can just write the symbol or the name. Molecules are very similar. To talk about molecules, we write something called the chemical formula. You don't need to write the definition down. And the chemical formula is something that looks like this. So on your paper, I want you guys to write down H2O. I'm sure you guys have heard of H2O before, right, in your other science classes. But I want you guys to just write this down somewhere on your notes, H2O, because I'm going to teach you guys how to interpret these chemical formulas, okay? Just copy this down for a second, so. Yeah, just H2O for now. All right, so let's talk about how to interpret these formulas. So these formulas basically tell you what the molecule is made out of. So if you take a look at the formula, we have H2O. So if we look at the letters, we have H, right? And if we go to the periodic table, if you guys remember, H is hydrogen. So that means H2O is made out of hydrogen. So let's write that down, maybe somewhere next to it. If we're answering number 4, H2O is made out of hydrogen. That's the first element that it's made out of. Okay, so H2O, the formula tells us it's made out of hydrogen. And if you look, there's another letter, right? It's O, my favorite element, right?
Mr. O.
Yes, it is me. Okay, so if we take a look at O on the periodic table, I want you guys to write down on your notes what element is O. So take a second. You can look on the periodic table, but write it down somewhere on your notes. Yeah, I think we talked about this yesterday too, but yesterday. Oh, it's right there.
Yeah.
Okay, hopefully you guys are able to see that O is oxygen, okay? So H2O, which is water, the chemical formula for water, is made out of hydrogen and oxygen. Okay, so the formula tells us what it's made out of, but it also tells you how many of each element there are. So easy way to look at it is if you look at these numbers, they kind of go on the bottom. They're called subscripts, bottom right of the elements. But these numbers apply to the element that's right in front of them. Okay, so since it's H2, that means there are 2 hydrogens inside of water. So one water molecule is made out of 2 hydrogens. And if you look at oxygen, there's no number behind it, right? So if there's no number behind an element, that means there's only one of that element. So water is made out of 2 hydrogens and 1 oxygen. Okay, and that's how you interpret these chemical formulas. Okay. All right, so let's check if you guys understand how to interpret these formulas. We have some longer ones right here. I want you guys to take about 2-3 minutes to work with the person next to you. Solve numbers 5 and 6 for me. For number 6, I do want to mention one thing. This right here is Cl, okay? We do not use iodine or element I in this class. It's because people get confused between the two, so just keep that in mind. Maybe on your periodic table somewhere, you can put like a light X through I, just to remind yourself that we're never going to use it. It still exists, right? It's still an important element. But for this class, just because everyone gets confused between iodine and some other ones, we just don't use iodine, okay? So just put an X through it maybe to remind yourself that we don't use I, okay? Okay, so I'll give you guys 2 minutes, 2-3 minutes to work on number 5 and 6. Try it out, check with the person next to you, and then we'll go over it in just a second, all right? Okay, so this right here is nitrogen. And the capital H is hydrogen. Okay.
Are there never elements that have like 2 capitals in them?
There's no, yeah, the capitals separate them. All right, so if you take a look at nitrogen, nitrogen has nothing behind it, no numbers, right? That means it's going to be 1. So you're going to have 1 nitrogen. If you look at hydrogen, hydrogen has a 4 behind it, so there are 4. Okay, good. Just to let you guys know, I put the confusing ones at the examples just to kind of help you guys understand it better. Most elements or molecules will be kind of short like this, so it'll be a lot easier. Yes.
Why is hydrogen just H, but why would helium just H?
It's just the way we name them. He. Helium is He. Yeah. Yeah, we use different symbols to differentiate them. It's from Latin. Yeah, Latin's natrium, and so yeah. What's up?
For number 6, like there's like 2.
Yeah, we'll get there. Yeah, I'll go over in a second. Any questions about this one so far? Okay, let's go on to S. If you take a look at the periodic table, S is going to be sulfur. It's right here. So we got sulfur. So we're going to write sulfur. And if you notice, sulfur has no number behind it, right? Which means it's just 1. And then we talked about oxygen earlier. So oxygen for O, and then there's 3 of them. Okay, so for number 5, we got 1 nitrogen, 4 hydrogens, a sulfur, and 3 oxygens. Okay. Okay, so just keep that in mind. The capital and the lowercase matter. That's why I mentioned make sure you always copy it exactly the way it is in the box. Okay, let's go to number 6. Number 6, I'm just going to write down the names for now. Si, hopefully you guys identified that that's silicon. Okay, there's capital H, which again is hydrogen. And then we have this right here. Okay, it kind of looks like Ci, but again, we never use I. We don't use iodine in this class. So if we take a look at this is Cl, okay? So if you go to the periodic table, Cl is right here. It's chlorine. And so that's what this element is going to be. Okay, so we got silicon, hydrogen, and chlorine. Okay, now, if you guys notice, hydrogen is written 2 separate times right here, right? Okay, that just means we add them up. So there's 3 hydrogens here on the left, and then 1 on the right. So that means we have a total of 4. Yep, we got 4. So if you ever see them separated, it's okay. There's nothing wrong with the formula. You just need to add them up at the end. Okay, if you look at silicon, there's no number, so that's going to be 1. And chlorine does not have a number, so that is also 1. And that's it. That's all our examples for today. That's how you interpret these formulas. Do you guys have any questions on this? This will be what's on your assignment and your quiz.
So we're gonna have a quiz after every time.
Yeah. They're usually like 5 minutes though. Should be pretty quick. Okay, so before we close up, I do want to kind of go over or summarize some of the or go over one more thing. So in this class, it's obviously chemistry, so we're going to be working with chemicals, right? Now, I know that chemicals kind of have a bad rap in our everyday speech, right? Chemicals are usually things that are like toxic for us and for the environment. But when it comes to chemistry, chemicals are just a simple term that we use to describe atoms and molecules. Okay, so take a second to write that down. Chemicals are just a simple term that we use to describe atoms and molecules. So pretty much everything that's physical, everything in the universe, in this class, we consider them chemicals. Okay, so water is a chemical. The air that you breathe is a chemical. You're made of chemicals. Okay, just want to take the stigma out of that word. We're going to be working with chemicals. Some chemicals are bad for you, obviously, but everything that is an atom or molecule, even things that don't harm us, are chemicals. Okay. And you guys don't need to write that last definition down, but chemistry, what we're going to be doing in this class is we're pretty much just studying what happens when we do stuff to atoms and to molecules. Okay, and so we're going to do a quick demo up here just to kind of show you some of the stuff that we'll be doing in this class and how, depending on what the chemical formula is, it actually completely changes how a chemical is going to react. Okay, so first one we're going to look at is carbon. Now, if you have a pencil, I want you guys to look at your pencil. And look at the very end of your pencil. What part you write with. That chemical is actually just carbon. It's a type of carbon called graphite. And so if we have carbon, right, graphite, and we, oh, no, okay, and if we light on fire, it doesn't really do anything, right? Okay, so that's kind of boring. But if we add 4 hydrogen, we combine that carbon with 4 hydrogen, and we heat it up, it actually completely changes what the chemical does, even though it looks very similar in terms of the formula. So I'm gonna do a quick demo, but I need a very brave volunteer. Can I get one? Oh my goodness, it's a lot. Okay. I can't really choose, but you're closest, so I'll pick you. But the rest of you guys, we can do the demo again. So if you can come up here real quick. Okay. Which hand do you not? Okay, that one. All right. So I want you to rinse your hand real quick, and then when you're done, you can turn off the water. Okay, so what I'm going to be doing is I'm turning on the gas, and the chemical that's coming out of it is the one that we saw earlier on the screen, CH4. Okay, so it's carbon combined with 4 hydrogen. Okay, so what I need to do is keep your fingers. I want you to take it off. However much more. So what I need to do is try to keep your fingers together. Just don't think of this. Okay, if I grab this. All right, so we're just gonna add some heat to CH4. And so as you can see, I can get a hand for our brave volunteer. Thank you for risking your life, so everyone can look. Yeah, but as you can see, it's completely different than what happens to regular C, right? CH4 does a completely different thing. And that's kind of the point of chemistry. Change the formula, you change what it does. All right, so that's pretty much it for me talking at you guys today.